Okay, so we talked a little bit in the last video about systems of equations. And in that video, we did systems of equations by using a graphing method where we graphed the two lines and we saw where the two lines intersected, and that ordered pair was a solution. Now, today we're also going to be doing some systems of equations, and they're all going to be linear. So we're going to have x's and y's, only two equations with two variables. And this time we're going to do a more algebraic method. We're not going to graph anything. We're going to do it using algebra. And there's two ways you can do it using algebra, and those are the substitution method and the elimination method. So for a substitution method, we're going to do this one first. So this little video will be on substitution method. There will be another video coming on elimination method. So we're just going to do a few examples on substitution real quick. So substitution says if two things are equal, you can replace one with the other. So I use the example all the time. If you don't have a dollar bill and you want to buy something at a concession stand that costs $1 and you don't have a dollar bill, you can pay with 4/4 because they have the same mathematical value, right? 4/4 equals $1. If you don't have 4/4, you can still pay for your item with 10 dimes or 100 pennies or 20 nickels, okay? So substitution means that if two things are mathematically equal, then you can replace one with the other. So we're going to use substitution method to help us solve a system of equations. So number one, we have a system of two equations here. We have y equals 3x is the first one, and x plus 2y equals negative 21. So what we're going to do is we're going to solve to get a x solution and a y solution. All right, we want to know what x equals and what y equals. Now we're going to use substitution. Now, this first equation tells me that y equals 3x. That means that y and 3 times whatever x is have the same value. So anytime I see a y, I can replace it with 3x. Well, there's a y right there in the second equation. So instead of having a y right there beside the 2, I can replace that y with 3x. And when I do that, everything else in that equation stays the same, except for where they once had a y, I now have a 3x. And now if you notice that equation right there, all of my variables are all the same. So if all the variables are all the same, these are all x's in that equation, now I can solve it for x. So I replaced my y with 3x because the first equation told me that y equals 3x. And now my second equation has all x's in it, and I can solve it. So first I need to multiply 2 times 3x, which is 6x. So I have x plus 6x equals negative 21. Combine my like terms. 1x plus 6x is 7x equals negative 21. Divide both sides by 7, and x equals negative 3. Well, x equals negative 3 now. So now I just have to find y. Well, now that I know what x is, I can go into this first equation and find y because y equals 3 times x. And I now know that x equals negative 3. So I can say y equals 3, and I can substitute that x with negative 3 because they equal each other. And 3 times negative 3 is negative 9. So y equals negative 9. So now I have an x solution and a y solution. So I can put my solution together in an ordered pair. And x always comes before y in an ordered pair. So you're always going to do x and then your y, okay? So it's going to be negative 3, comma, negative 9. This is my solution. So you could have got the same result if you were to graph those two equations. So systems of equations have mainly three different methods that we use in Algebra 1. So if I were to graph these two lines, put them in slope-intercept form and graph them, these two lines would cross at the point 3, negative 9. Now, it would have a y-intercept of negative 11, a negative 10.5, which would kind of not be very useful to us. That's why sometimes algebraic methods are better than graphing methods. but they both get us the same solution no matter how you do it. So substitution method, you want to find a variable that equals something, and then you replace everything with what that variable equals. So let's do another one. Number 2 tells me that y equals 3x plus 2. So anywhere I see a y, like right here in the second equation, I can replace that y with 3x plus 2. So that's what I'm going to do. I'm going to copy that whole equation, x plus 2. But when I come to the y, I'm going to use parentheses, and I'm going to insert 3x plus 2. And then finish the equation, equals 11. So everything is the same in that second equation as it was originally, except for where I have in parentheses used to be where y was. But since y equals 3x plus 2, I replace that y with 3x plus 2. Okay. So now I have all x's in that equation, so I can simplify and solve that for x. So copy this x, and then I'm going to distribute. 2 times 3x is 6x. 2 times 2 is 4. Equals 11. These two terms are like terms. So 7x plus 4 equals 11. See if I have room here. Barely. I'm going to subtract 4 on each side. 7x equals 7. Divide by 7 on both sides. And x equals 1. Okay. So now I know what x is. So all I have to do now is find y. Well, to get y, I'm going to go to the first equation. Y equals 3x plus 1. I now know what x equals, so I can plug my x value in right there for x. So y equals 3 times x, and my x down there, I just found out x equals 1. So replace 1 where the x was, and then copy your plus 2. Then you simplify. 3 times 1 is 3, and 3 plus 2 is 5. So my y value is 5. Put them in an ordered pair. X comes before y, so 1 comma 5. And there's my solution to that system. Okay, so if we know what something equals, we can replace it with that variable. All right, let's do one more. I'm kind of draw a line here to separate my problem. I'm sorry, that last problem kind of got in my way. All right, this one, they tell me that x equals 2y minus 6. And when we're using substitution, we want to find a variable that equals something, okay? So this one, they tell me that x equals 2y minus 6. So anytime I see an x, I can replace it with 2y minus 6. So in this second equation, here's x. So instead of writing x there, I can use parentheses and substitute 2y minus 6. So that's what I'm going to do. I'm going to copy everything else the same. So I'm going to say 4, and instead of writing x, I'm going to do parentheses 2y minus 6, and close my parentheses, and then I'm going to replace or copy everything exactly like it said in that second equation. So this is where x originally was, is where that parenthesis is. And now my equation has all y's. So now I can solve this one for y. So sometimes you solve for x first, and sometimes you solve for y first. It doesn't really matter which one you do first. Just when we put our ordered pair in at the end, we want to make sure it's x, then y. All right, so I have to distribute first. 4 times 2y is 8y. 4 times negative 6 is negative 24. And then copy plus 6y equals 4. Well, I got two things with y's on them on the left side. So these 8y plus 6y are like terms. So 8y plus 6y is 14y minus 24 equals 4. And then I add 24 to both sides. And 4 plus 24 is 28. So 14y equals 28. Divide by 14. I don't know if I have space or not. Barely. I'm going to do it over here. So y equals 2. So now I know that y equals 2. So that will help me to find x. Well, up here, x equals 2y minus 6. And now that I know that y equals 2, I can plug that in right there and get my x value. So x equals 2 times 2 minus 6. Simplify that. 2 times 2 is 4. And 4, I don't know why that got so big. And 4 minus 6 is negative 2. So my x is negative 2. My y is positive 2. So put them in an ordered pair, x then y. So negative 2, comma, positive 2. So that basically in a nutshell is how you do substitution method. Again, when you do substitution, you want to do that when you have a variable that is set up equal to something else. So if it says x equals blah, 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 or y equals blah, 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 that's when you want to do substitution method. The rest of the time, you will probably want to do elimination method if that's your preference, and you can watch that in the next video.